Welcome to a lesson on exercise 6E, exploring gradient, where we talk all about gradient. Um, Before we start, or as we start, right, what is gradient? Gradient is simply the slope of a line. Now, when we look at graphs, from a graphing perspective, what is a straight line? You have to understand, okay? From a graphing perspective, what is a straight line? And the answer is a straight line has the same gradient throughout. And that's a very, very informal definition. I completely made it up, but it's true. It might not be a formal definition per se, but it's certainly true. And it's something that you need to understand. So a straight line has the same gradient throughout. Now, so what is gradient, you might ask? And gradient is simply the slope of a line. So imagine you're playing Mario Brothers or some 2D platform game. I don't know what you guys play nowadays. And, imagine that's the game. And this line would represent the slope. Now, if this gaming character is going uphill, then the gradient, the slope would be positive. So imagine this line is actually going like this. Then this guy is going uphill, the gradient would be positive. But if the game character was actually going downhill, kind of like this, then that would be downhill, and the slope, the gradient, would be negative. So slope gradient is just, which way is the line pointing? That's it. Now, mathematically, we have to be more precise. We have to describe it using numbers, how steep a line is, how shallow a line is. And the way we do that is as follows. We say that if you had a graph, and obviously we know this is the x-axis. We know this is the x-axis, and we know that's y. And we don't actually write axis, we just write x. So I'll just cross that off. And gradient or slope, mathematically speaking, is how high does it go for every 1 unit that you go to the right. Okay, so I know it's 1, 2, 3, 4, and so on. And gradient is how high you'll go for every 1 unit you go right. For how high or low, so you go up or you go down, but how much will you go up or how much will you go down for every unit you go right? That's the mathematical definition of slope, of how steep or shallow a line is. Mathematically speaking, how would you tell someone, if I said draw a line, and then you'd be like, okay, do you want me to draw this line or that line or this line? Which line are we talking about? There's so many different possible lines. And one thing that you could tell me is the steepness of the line. You could say like that, or you could say like this. And the way you describe that is how much do you go up? How much do you go up for every 1 unit that you go to the right? Okay, so for every 1 unit, if that's 1 unit, then how high do I need to go? If it's a very steep line, then you'll go this high. If it's a very shallow line, then you'll only go this high. Hopefully that makes sense. All right, so let's get started finding out the gradient using numbers and more concrete terms. Okay, so I'm going to use this, and I'm going to show you a visual method, same as the previous exercise, followed by a more algebraic / numbers numerical method. Okay, so obviously, as you can see, many different lines are possible. Okay, now we did say that if a 2D character is standing, around over here, and walking towards the right, this would be uphill, the gradient would be positive. And if they were going downhill, the gradient would be negative. I hope that's clear. This will be a negative gradient. This is a negative gradient. That's a negative gradient, okay? They're all negative gradients, but if you're going uphill, remember your character's over here and moving to the right. And if you're going uphill, it's going to be positive. All right, let's get started. Now, what you want to do is gradient is rise over run. How much you go up every time you go right. And let's start off with the simplest one. Then the gradient of this line, every time you move across by 1, you go up by 1. And so the gradient of this line is 1. Okay, and I might turn the coordinates off. Is there a way to turn that off? I don't think so. It doesn't say. That's okay, no worries. So if you have this line, then in this line, the gradient would be 1. Okay, the gradient is 1 because rise over run. Gradient is, okay, I'm just gonna wipe it all off. Okay, so rise, how much it rose between those 2 points? How much did it rise? It went up by 1. And how much did it go across? 1 as well. So the formula, mathematical formula, would be gradient is equal to rise over run. Rise over run. So how much did it go up? And over here, how much did it go up? It went up by 1. Rise means how much it went up. Run means how much it went to the right. So 1 over 1, which is just 1. Okay, so let me clarify. Earlier, I was saying that gradient is how high, low you'll go every 1 unit you go to the right. And now I'm saying how much you go up and how much you go right without referring to 1 unit to the right. And the idea is you write the gradient as a fraction. For example, what would be the gradient over here? And let's have a look. Okay, now you pick 2 points on a line, any 2 points on the straight line, doesn't matter which 2 points you pick. Obviously, we've chosen these 2 points. We've chosen this point and this point. Now, how much does it rise? How much does it go up from here to here? How much does it go up? It goes up by 1, 2, 3. So rise over run is the gradient, and that's going to be rise is 3. And how much does it go across? It goes across by 1, 2, 3, 4, 5, 6. It goes across by 6. 3 over 6, which is 1 over 2. And so the gradient is gradient is equal to a half here. For every 1 unit that you go across, you go up by half. Okay, so this is consistent with my earlier definition. Gradient is how high, low you'll go for every 1 unit you go right. How do you find gradient? You do rise over run. You pick any 2 points on a straight line, you look at rise, you look at run, and that will give you the gradient. That will tell you how much the line will go up for every 1 unit that you go across. And so we said for this line, the gradient is a half, and we can verify. Let's pick any point we want. Let's say we pick over here. If you go across by right, if you go across by 1, how high will you go? Half, as expected. Okay, so let's look at another example. Let's look at something like this, for example, a lot steeper. Let's say, I'll choose, yeah, why not? Okay, as good as any. Okay, and so we've chosen this line. All right, now, same as before, we say gradient of this line. Gradient is going to be rise over run. Gradient, to find out gradient, we do gradient is equal to rise over run. Now, you could pick any 2 points, and I'll choose 2 points in a second. But there's 2 points have been chosen for me already, the red ones. Okay, rise. We look at this, and this often helps. It often helps if you do this, and you draw a triangle. It can help. It can help you see the rise and the run. How much is the rise? How much have you gone up? And obviously, you've 3 rise over run. Now, this is a negative gradient because you're going downhill. Okay, so you put negative first up. Then how much was the rise? The rise was 3. How much was the run? Well, 1, 2. And so the gradient is negative 3 over 2, which is negative 1.5. That's equal to negative 1.5. Now let's test for every 1 unit. For every 1 unit that I go across, how much will I go up or down? And I'm saying it'll go up or down by 1.5. So let's see. If I go across by 1, how much am I going down by? 1.5. So that's gradient. How much you go up or down every single time you move to the right by 1. And you calculate gradient by doing rise over run. Now, do one more example. This time I will enable that. So that helps a lot. Let's do one more example, for example, like this. And drawing those lines, those dotted lines, is a ridiculously useful way to make sure you don't make a silly mistake. You just really, really visually see it. Okay, visually see it. How much is the rise? Rise is 1. Is that a negative line? Yes, it is. Negative 1 over. How much is it going across by? 2, 4, and 1, 5. And the gradient is negative 1 over 5. That's it. Like, that's gradient. That's how you find gradient. It's very straightforward. And yeah. All right, now I'm going to go back, and using a red pen, I'm going to do it using the algebraic method. Now, the algebraic method says that the gradient, M, refers to gradient. I don't know why it's M. It just is. Just deal with it, I guess. M is equal to change in Y over change in X. And that's often written like this: Y2 minus Y1 over X2 minus X1, which looks fairly complicated. And all it means is, see how you have 2 points over here? You have 3, negative 1, and you have negative 4, negative 2. Then what you do is, this is X, this is Y. I'm going to label this X1, Y1, X2, Y2, and Y2 minus Y1. So if you want to do it using algebra, you would say, what's Y2? Y2 is negative 2. So you'd set it up. Because it's a negative number, use brackets, negative 2 minus Y1. Y1 is negative 1. It's a negative number again, so I'm going to use brackets again. All over X2. Well, that was X2, negative 4. So in brackets, negative 4 minus open bracket. What's X1? X1 is 3. Use brackets anyway. And just put the whole thing in your calculator, and it will give you the answer. So you have open bracket, negative 2, close bracket, minus open bracket, negative 1, close bracket, all over open bracket, negative 4, close bracket, minus 3, something negative. I don't need brackets. 1 over 7. 1 over 7, which I've clearly made a mistake. What? It's supposed to be 1. What happened? Negative 2. Oh, I did X2. Oh my God. I did the wrong thing. I did X2 minus X1 stuff. Okay, so clearly I don't use the algebraic method often. I prefer the visual method. Anyway, let's do it again. Okay, another thing is, this is supposed to be negative, because that is a negative 3, negative 1, negative 4, negative 2. And we are going to do Y2 minus Y1. I did it right. I think the only mistake was this. Yeah, the only mistake is this, because I didn't have that negative sign. So if you do this, if you go back and open bracket, negative, close bracket, you get 1 as expected. You get the same answer. So we got 1 over there earlier. We got 1 now as well. Sorry, silly mistake from me. Moving on. Now, if you're going to use the algebraic method, I would strongly prefer use this. It makes it a lot easier to think about. So let me demonstrate. So now that's -4, -2, and you have 2, 1. And so what is the change in y? Let's say we're going from here to there. So the change in y from -2 and 1. What is the change between -2 and 1? If you had a number line, and yeah, that's 0, and that's 1, and that's -1, and that's -2. What is the change in y? The difference between -2 and 1, and that's obviously 3. 3 over change in x. Okay, so let's go back to our definition. Gradient is change in y over change in x. So that's what I'm doing. Change in y over the change in x. Change in x between 2 and -4, it's going to be 6. And I'm done. That's equal to 1 over 2. And that's the same as before we got earlier, half. Okay, so change in y over change in x. Now, you might be wondering, why am I showing you the algebraic method at all? Well, okay, sometimes you'll get a straight line, and sometimes it'll just be like, what is the gradient between the points. I'm just gonna make something up, 3, 5, and I don't know, -2, -4, whatever. Okay, and in this case, one approach would be to graph or draw up this and then say 3, 5, 1, 2, 3, and then you go 1, 2, 3, 4, 5. You put a dot there, and you go -2, -4, -1, -2, and then -1, 2, 3, 4. That's -4, and you put a dot here, and then you do it using the visual method. You look at the rise, you look at the run, and so on and so forth. So you draw a dotted line going down, and then like that, and you think about rise of run. Another way you can do it is simply just to change in y over change in x. What is the change in y between -4 and 5 on a number line? Visualize the number line. Think about how much does it change. -4 to -5 is 9. And then change in x from 3 to -2 will be 5. And that's your gradient, 9 over 5. So change in y over change in x, gradient is equal to change in y over change in x, and that's over here equal to 9 over 5. And if you do it using the visual method, you'd get the exact same answer. So this can be useful, change in y over change in x. To use it, you need to have a strong grasp of a number line. You need to be able to visualize the number line, and you need to be able to say, okay, between -4 and 5. So you have 0 here, 1, 2, 3, 4, 5, and you have -1, -2, -3, -4, -5, -6, whatever. So -1, -2, -3, -4. And then you'd say the change in y is from -4 to 5. And so in this all visually, you're doing this mentally in your mind. From -4 to 5. Well, there's going to be 5 from 0 to 5, and there's going to be 4 from 0 to -4. So 5, that's 4, and that's 5. 5 plus 4 is 9. And that's how you get 9. How you can do it mentally. Okay, I believe that's all of the exercise. I'm just going to flick through the worked examples. Yes, I should do horizontal vertical lines. Yes, I think I've covered everything else. Okay, so last thing before you guys can go is let's think about vertical and horizontal lines. So let's say, for example, you had that. And let's say, for example, you had a line like this, and let's say that's 4. Let's say that's 2. How would you write the gradient of such a line? How would you write the gradient of such a line? And very simply, often students, how should I say this? Okay, okay, look. So see how x over here is going to be 1, and then x over here, this is the x-axis we are talking about. X over here is going to be 2. X is going to be 2. And so the equation of this line, because it's x equals to 2, throughout this line, this line has an equation x equals to 2. Okay, but what is the gradient of this line? Now, the gradient of this line is given by change in y over change in x. Now, how much does y change and how much does x change? Is x changing at all? X is not changing. That's going to be 0. And therefore, because you cannot, in case you didn't know this, so this is something you may learn new, you can't have 0 at the bottom in a fraction. It breaks all of mathematics. If you do advanced maths next year, we'll go into this a lot more detail, but you can't have 0 as a denominator. This is one of the big fundamental laws of mathematics and of fractions. So this line has no gradient. No gradient. Okay, no gradient at all because 0 is at the bottom. X is not changing. Now, over here on the right-hand side, to have a horizontal line, the equation of this line will be y equals to 4 because, the equation of the line is y equals to 4. But what is the gradient of this line? Well, change in x, change in y over change in x. Let's think of it in terms of this. How much is y changing? Y is changing not at all. Y is not changing. Y is always going to be 4. So it's going to be 0 over anything. It doesn't, the bottom doesn't even matter. Now, how much does x change? Well, x changes all the time, infinite amount. Like it just keeps changing, right? But 0 divided by anything is just 0. So the gradient of this line is going to be 0. So m equals to 0 for this line. So horizontal lines have a gradient of 0. Vertical lines have no gradient. I hope that's simple enough. And I've explained why. If you ever forget which one's which, just do an analysis over change in y over change in x. And just think about it. And remember, you cannot have 0 at the bottom of a fraction. That makes the whole thing invalid, and therefore it'll be like no gradient. Okay, so that's it for today. Please do exercise. Which is this? This is exercise 6E. Exercise 6E. Questions as marked in the book. Best of luck.